Hello everyone, welcome back to Software Testing with Ree. In today's beginner-friendly Python tutorial session, we'll dive into some of the most important fundamentals you need to master. We'll cover Python data types, checking types and memory addresses, typecasting, and difference between identifiers, variables, and literals. And finally, we'll explore arithmetic operators in detail. So let's get started. So first of all, we'll create a new Python file. So just right click on this and new file, Python file, and let's name it lecture 2 and hit enter. And now let's start with the Python data types. Although in Python we don't need to declare a variable type or data type of a variable before using it, uh, but this information is vital for the interpreter. And Python supports following type of data types. Let's write it Python data types. So it supports integers, then which is set as int, and then it supports float, and next it support as complex numbers, and lastly it support as strings. So let's see one example or some example for each of these data types. First, let's start with int. So integers are numbers like 1, 2, 3, or like these kind of numbers, or minus 10. So which are like round off. There is no decimal value included. So if we write a is equals to -7, and then we say print type a. So basically we want to see what type of variable a is, or what type of data type is stored in a. So let's run this, and you see it is of integer data type. So this is how you can check, or you can also set like any size of number, but it all depends on like your memory capabilities of your computer. So if we run print b equal to 99999, a huge number, and then we set print type b and we run it, so we'll get int for it as well. So there is no limit for how long or how big number you can put in type variable, but all depend on the memory of your computer. So this is about int variables. So let's comment it out now. Now let's talk about the float variable. So float variable data type is something that contains numbers in like decimal, with decimals like 2.5, 1.5, or 1.33, or 0.33, so on. So let's write a similar program for checking the float data type. So let's say we write a is equals to 3.1, and then we print type a, and let's run this. So we should get a float for this. So you see we got a float for our a equal to 3.1, whereas in case of a equal to -7, we got uh, int as our data type. So this is our float, and this is how we can check the data type for our variable, or that we are kind of storing our data type into. And another is like the complex numbers. So Python also supports complex numbers. So if we write a is equals to 2 plus 3j, and then we write print type a, and now run it, so we should get a complex as output. So you see the data type for a now is a complex number. So this is a complex number data type. The next data type that Python support is strings. So string is a sequence of characters basically, and Python do not have a char data type. just like C++ or Java. So you can delimit a string by like a single quote or double quote like we saw in the first lecture. So let's say we write city equal to New York, and then we write print type and city, and if we run it we should get a string data type as our output. So you see it's our this is the string data type. Now let's say we want to check like where our stored variable is stored and what is its data type, and let's say we have a and city and a, and now we want to know what is its data type and where memory location of its storage. Memory location. So in that case, we can use first is like we already saw type function. This is inbuilt Python function that you can use to like know the data type for your variable, and then we have ID function to know the memory address. So let's say we have two variables. One is a equal to 3.1 and next is let's say b is equals to 5, and now let's say we want to know the memory address and mm, uh, the data type for each one of this. So let's first start with a. So we'll write print type and then let's put a, and now next we want to print as print id of a, and similarly let's write like this. So we'll write a and then comma data type of a, and this is memory address of a, and let's put a comma. So we'll get here looks like okay. So let's remove this. Yeah. So this should give us the data type of a and memory address of a. Similarly, let's copy for and paste for b and city. Now let's put b and here we put city, and also let's change here as well city b and b. So this way we are going to get the data type for each of our variable and their memory address. So let's run this, and you see we got a has a data type of float. That's what it is. It has a value of 3.1 and its memory address is something within the memory like a huge number, which basically is like either binary, so you can like identify like it's located within your memory somewhere. And similarly we have for b and city. Let's not complicate our like, since this tutorial is for beginners, so we will not go into detail for now for memory addresses because we will not be needing it for now, and when we'll need it I'll explain it in more detail. So a main objective here is to show you like you can use type function to know the data type of your variable, and you can use id function to know the memory address where your data type is or your variable is stored. And we are going to use both of them pretty soon, so just keep this in your mind and we'll use it in coming lectures. Now let's comment this all and move to the next part. So first let me comment it. Okay, and comment this as well. So, in our first lecture, we talked about variables, and then we talked about identifiers, and next we talk about literals. So, let's clearly understand what they really mean and how, like, I'll be using them more often, so it's much better to let's get a clear definition what they really mean, so it's easy for you to understand in future lectures, or you don't get confused with these terms. So first is variables. Variables are containers to hold value, to hold values, like we put a equal to 5, or city is equals to New York. So in this case, we have city and A are our variables. Now is identifiers. So identifiers is the name given to variables or functions. Given to variables, functions, etc. So like we here we gave name as A and city. These are two variable names that we use. So these are our identifiers. And next is literals. So literals are basically the actual value, values that is assigned to our variables. Assigned to variables. So now I hope you have a clarity about what is variable, what is identifier, and what is literal. So identifier is basically the name of the variable, and variable is basically that is a container that holds value, like a holds the value 5, and literal is the value of the variable or that's it's holding, like 5 is a literal and New York is a literal. Now, the next topic I want to cover in this lecture is typecasting. Let me put in comments. So, basically, what it means is type conversion in Python. So, what type conversion basically means is in programming, type conversion is a process of converting data from one type to the another. For example, we convert int data type data to string. So this is kind of a process. It's called type conversion. Also, typecasting is a method to convert the variable data type into a certain data type in order to uh, perform any operations that we want to perform. So there are two type of conversions in Python. One is implicit conversion, which is automatic type conversion, and next is explicit conversion. Oh, sorry, which is manually we do the type conversion. So now let's first look at implicit type conversion. So in this method, Python converts data type to another data type automatically. In this process, user don't have to don't have to get involved in this process of data type casting. And let me show you some examples. So let's say we have a equal to 7, and we say print type A. So Python, like if we put any number, so Python automatically knows it's a number and it automatically gives it a int data type, and like you see. and if I put b equal to 3.0, so and I say print type b, and if I run it, you'll see like int and float for b. And if I put like this is how Python automatically converts. And let's say I put c is equals to a plus b, and then I print type c, and if I run this, we should get a complex float for c as our data type. So you see, so we had int in a and float in type b, or b for our b variable, and when we printed the sum of both stored in c, we got like a float. So this is how like Python automatically adjusts the data type. Let's say we define a variable a, and we say we define a variable d, and we say a into b, and now we do the same. We write print types d, and we should get a float. So you see, so in this kind of situation, we don't have to get involved in type conversions. Python automatically take care of these kind of conversions. Now let's look into what is explicit type conversion. Let's first comment this out and see. So explicit type conversion is a method in which Python needs users' involvement to convert the variable data type into a certain data type in order to do any kind of operation that user wants to do. So mainly the in typecasting can be done for data types like integer, float, and string. So we can do typecasting for integer, float, and string. Now let's see some examples for it. So let's say we have a is equals to 5, and now we want to see convert it to float. So we say n is equals to float a. So this is how we converted our a data type uh, into float, which is like a was integer. Now we just converted the data type of a to float. Now if we type like print uh, a, type a, and we say type a, and let's do the same for n, and if we run this, we should get integer for a and float for n. You see, this kind of type conversion is called explicit type conversion. Here we converted integer to float. Integer to float. Now let's do a conversion to from float to integer to int. Let's comment this out for now, and let's say we have a is equals to 5.9, and now we say n is equals to float a, and now if we type the same thing here and run this, and let's uncomment this as well. So we should get let's not float, let's write int. So now we have a float in a, and we want to convert it to int type, and let's run this. So you see, now our float is converted explicitly into int type. So this is like the conversion of float to int. Now the next I want to share is the data type conversion from int to string. So we can write a is equals to 5, and then n is equals to str and type a. So our integer is converted to string. So now let's copy this and run this. So we should get string data type for our n variable, and for a we should get int as a data type. So you see, we converted from int to string, and next let's see converting from string to integer. String to int. So we can write a is equals to 5, and then we write n is equals to int of a. So we converted n to like a to integer data type, and let's run this now. So for the topmost we should get a data type of a string, and for n we should get a data type of integer. So we got string as for a, and for n it is data type is integer. So this is like the explicit conversion. Lastly, let me show you how to do the type conversion for string to float. So let's write here string to float, and let's first comment this out. And so let's say we have a is equals to 5.9, and now we want to write like n should be float of a. So we want to convert a to from string to float, and then we write the same thing to check the data type of this. And let's remove this and run this. So we should get for a as string, and for n we should get a data type of float. So you see, we have n. Let's write it here like n comma, and let's a comma. So we do a, and then we do comma, and let's write here n comma. So now we will get the a and its data type, and then n and its data type. So let's run this. So you see, we have a has value 5.9 and it has a type of string, and in case of n we have the same 5.9 value, and now its type is converted to the float. So this is all about typecasting in Python. So you can like you can directly perform mathematical operations like we did here, like d equal to a into b, where we had like a as integer and b as like float, and we got d having a data type of float. Implicitly Python took care of it, and then we saw some type conversions using explicit method for int, float, and string data types. So I hope it is clear for you for now, like about typecasting and how we can do it. And next we are going to talk about is Python operators. So now let's talk about Python operators. So in Python programming, operators in general are used to perform operations on values and variables. And these are the symbols we use for the purpose of logical, arithmetic, or various other operations. Let me put it in simple words. So we have operators with the symbol like multiply, divide. These are kind of operators. These are examples of arithmetic operators. And let's say we write 5 plus 4. So here 5 and 4 are our operands, and the plus symbol is our operator, which is like the plus operator. And Python in Python operators, we have following operators available. So we have arithmetic operator, arithmetic. Next we have is comparison, then or relational operators. And next we have is logical operators, assignment operator, membership operators, and lastly we have is identity operators. For today's session, we'll be diving or looking into deeply into arithmetic operators. So in arithmetic operators, we have plus or addition operator. Next we have is subtraction operator, multiplication operator, division operator, modulus for remainder, exponent, and lastly we have flow division operator. So let's we'll see each of them in with examples now. So let's start with addition operator. So let's say we have a is equals to 9 and b is equals to 4, and we can write add is equals to a plus b, and let's say we write print add, and let's run this. So we should get 13 as our output for add. So you see we got the value of add as 13, which is like we used add operator here. And now let's try to use subtraction operator. So we let's write it here, add in addition. Now let's do for the same for subtraction. So we write sub, and then we write a minus b, and then if we write this and let's run this, so we should get 5 as our answer. So you see we got 5 for our subtraction, and na 13 for our addition operator. Now let's check multiplication. The same thing, we'll write mul is equals to a into b, and then print multiplication mul. So you see we got 9 into 4 is 36. That's what we got for multiplication. Now let's try division. So we write div is equals to a divided by b, and then we write division equal to b. So basically what it's going to do is 9 divided by 4. We should get 2 as our output, and we will not get the remainder value here. So oh yes, it gave us like in float the value when we divide 9 divided by 4. But like it's like implicit type conversion that happened here, because we didn't define the data type for div. Python automatically converted the integers division to float. Whereas in case of C++ or Java, you'll not get this thing happening. You'll have to explicitly tell like what you want. And next is the modulus operator, which is basically the remainder. So we'll write mod is equals to a percentage b, and then modulus. So you see 9 divided by 4 is 2 and we should get 1 as remainder. So let's run this and see what we get. So you see we got 1 as our remainder, like I said, with the modulus operator. Now let's check the power operator or exponent operator. So this basically means is 9 raised to the power 4, which is multiplication of 9 4 times. So let's run this and we write exponent is equals to, let's write power p is equals to a double multiply b, and let's print this, not percentage power, and we are expecting like 9 raised to the power 4 is 6561, and that's what we got here. So these are the operators. Lastly, we'll see the floor division concept. Now let's talk about the floor division. So in this division operator, we saw like we had a and b as integers, and still we got a div of data type float. This type of division is called float division, and in float division we get like will not get this remainder as our output. We'll get only 2 values. So this is called the floor division. So we'll just get the divisor, not the remaining like further division through float method. So let's check it out. So we write um, div 2 div floor is equals to a divided by b, and now let's run. And if we run this, why this is going error? There is some typo. So let's floor d floor. Let's run this now. D floor. Oh, it's still giving some warning, but let's run. Yeah, so like I said, in floor division, we get just the integer value of the division, not the further division like we got for float division. And we can call simple division as float division as well. So yeah, that's all for uh, our arithmetic operators. So we covered addition, subtraction, multiplication, division, modulus, power or exponent, and float division for our arithmetic operators in Python. And we also have like parentheses. We'll cover that in coming lectures. So thank you so much for watching this video. If you found it helpful, please don't forget to like, share and subscribe to my channel, which is Software Testing with Ree. I'll see you in the next video.